Okay, after we studied the preparation of aldehyde, now it is time for the preparation of the ketones. Okay, in the preparation of ketones, there are not much different methods. Some common methods are there. Okay, so in the common methods, like differences, I will tell you with that method and this method. So if you studied that perfectly, then it will be easy for you to understand ketone preparation. Okay, this method is common in the aldehyde. This should be 1 degree alcohol. Okay, if we take 1 degree alcohol, we will get the aldehyde. 1 degree alcohol will get the aldehyde. And if we take this 2 degree is also called as a secondary. Okay, so this is the carbon on which OH is connected, and this is connected to two alkyl group. This is connected to how many alkyl group? Two alkyl group. That's why it is called as a 2 degree, or what it is called as secondary. Now when it is oxidized, see, this is the oxygen, nascent oxygen. Who is going to provide you nascent oxygen? PDC. What is PDC? Pyridinium dichlorochromate. This full form and everything I have told you. PCC, pyridinium chromyl chlorate. Okay. So in the aldehyde preparation only I have explained with formula. And CH2Cl2 is the solvent in presence of CH2Cl2. Okay. PCC is used in the non-aqueous medium. Non-aqueous means water should not be present. Any solvent other than the water, any solvent other than the water is used. That is non-aqueous. Okay. Here solvent is what? CH2Cl2. Secondary alcohols on oxidation with PCC or PDC gives ketone with the same number of carbons. See here, no CO2 is liberated. Okay, so that means suppose in this aldehyde, sorry, in this alcohol, 7 carbons are there. Here also there will be 7 carbons only. Okay, ketone with the same number of carbons will be there. But problem is that if strong oxidizing agents are used, then problem. This will be further oxidized. Strong will not stop after the ketone. It will further oxidize. Then it will be giving you the carboxylic acid. So never use strong oxidizing agent, because strong oxidizing agent instead of a ketone, it will further oxidize to carboxylic acid. So we require ketone, so use mild oxidizing agent. If you require carboxylic acid, then we will use the strong oxidizing agents like KMNO4, K2Cr2O7. What are the strong oxidizing agents? KMNO4 or K2Cr2O7. Okay, here we are not doing the complete oxidation. That's why it is called as a partial oxidation. That means we are stopping. See, I will write it here. Alcohol. Okay, this is useful in the conversions, which you will get in the board exam and as well as in the competitive exams. Alcohol on partial oxidation will give you aldehyde, okay. Otherwise, ketone, it can give you aldehyde or it can give you ketone. But one more partial oxidation, then it will give you the carboxylic acid. Okay. So this is partial, either two partial or one strong oxidation. One strong oxidation will give you the carboxylic acid. One strong oxidation will give you the carboxylic acid. Okay. Okay, in the second preparation we have dehydrogenation. See, D means removal, hydrogenation means hydrogen is removed from the alcohol. Here also same. Okay, so here this will be the hydrogen. Actually print mistake. This is 2 degree alcohol. Okay, so 2 degree alcohol, when dehydrogenation, see, two hydrogens are eliminated. Okay, then this bond will shift here. Mechanism, are you able to understand? RC, ikkada single bond. Here one single bond is there. Now there will be double bond. There will be what bond? Double bond. RCOR plus this hydrogen and this hydrogen. Now it will be H2. Understood? But if you do it at the 300 degrees Celsius, okay, then it will be H2. But if you use air, that means air oxygen will react with this hydrogen, then what will be formed? Water will be formed. These two product, our required product is same. What is the required product? Ketone only. In this method, there is no risk of further oxidation of aldehyde and ketone. Why this method is advantage? In the question, reasoning question will be there. Why copper or silver at 300 degrees Celsius is best method to prepare aldehyde or ketone. So by chance also they will not further oxidize to carboxylic acid. Is it understood? And this is the cheapest method. That's why industrial method. So if they ask industrial method only in the board exams, you will write this method only. Okay. So let us see the next one. Now next slide, let us see. Here next slide is about the by the dry distillation of calcium salt. Same procedure we have studied in the aldehyde also. Same procedure we are studying in the ketone also. What is the procedure? Dry distillation of calcium salt. Okay. So this procedure is suitable only for the symmetrical ketones. Symmetrical means this is R, then this will be R. If I write like this, then it will be clarity to you. Okay. If this is R, then this must be R. Suppose if it is R dash, then it will be mixed ketone. So for them it is not possible. So I will tell you shortcut to remember. What to remember? This is the calcium, okay, and this is the CO, and this is the O. This is the R, this is the C double bond, this is the oxygen. Same way here R, C double bond, oxygen, C. This is the complete detailed structure. Now CaCO3 I have to eliminate. So which is your favorite color? Green. Okay, so I will take green color. Okay. Now CaCO3. See, this way it will cut down. Okay. So CaCO3. So this gave the CaCO3. Now what is left over here? RCOR. So RCOR is what? Symmetrical ketone. Is this mechanism understood now? So this way if you make multicolored pen notes, then it will be interesting. You yourself will come to see the notes. Understood? So this is the preparation method. Dry distillation. We are not using any water. Okay. Directly we are getting the ketone. Understood? And calcium salts of dicarboxylic acid. Actually, this is a top secret. Don't tell it to anybody. One day it was like this. This is one carboxylic acid and this is another carboxylic acid. Okay. So one day what happened? One calcium hydroxide came. Calcium hydroxide was purple color. Which color? Purple color. Okay. CaOH and CaOH. So that day what happened? H2O eliminated. H2O eliminated. Now this gave you the dry calcium salt of dicarboxylic acid. What is this? Calcium salt of dicarboxylic acid. I think it is understood. Then produce 5-6 membered cyclic ketone. If in this one there are more carbons are there, they will give you the ketone only, no problem. But if 5-membered ring like this, pentanone, cyclopentanone, this is a 5-membered ketone. Okay, 6-membered ketone is very, very interesting. What is that? This is the 6-membered ketone. Okay, so 5-membered, 6-membered ketone, I think it is clear to you, all of you. Now let's see the next one. Okay, so next method is by the reduction of carboxylic acid. Already, see, I will tell you here RCOOH is there. So one extra oxygen is there. We want only one oxygen. That time we will use the reduction. The addition of oxygen is oxidation and removal of oxygen is reduction. Here extra oxygen is there, extra oxygen, that oxygen is removed. And who will go and remove to the acid? Our manganese dioxide. The purpose of manganese dioxide is to pick up OH from the one carboxylic acid and H and CO2 from the other carboxylic acid. So this will be H and CO2, H2O, CO2, and this will be RCOR dash. RCOR dash, that is ketone will be produced. Is that clear? So for example, if I want to, if I use acetic acid and if I use propanoic acid, so acetic acid and propanoic acid, then one side acetic acid 2 carbon, another side 1 carbon is eliminated. See here always you should remember 1 carbon less, because 1 carbon is removed as what? Carbon dioxide. If I use, see here, 3 carbon here and 2 carbon here, 5 carbons are there, but here how many carbons are there? Only 4 carbons are there. Where that extra carbon went? That extra carbon went as a CO2. Is it understood to all of you? Aldehyde and ketone. Okay. So I think now it is clear. Now let's go to the next slide. We will do the practice. More practice is required. Okay. Now let's see the next slide. By the hydrolysis of alkenes, this I already told you in the aldehyde preparation also, Wacker process. But in Wacker process, if we use CH2 double bond CH2, terminal, what? Terminal. This side also no carbon, this side also no carbon. That time it will give you the aldehyde. But here there is a CH3 here. What is here? CH3. So PdCl2 plus H2O. Here already it is given all alkene except ethene. If I use the ethene, then I will get the aldehyde. Other than ethene, like propene or butene, anything if you use, you will get what? Ketone. Okay. So this is the ketone, but reagents are either CuCl2 or CdCl2 in presence of PdCl2 and H2O. Wacker process, I think it is clear to all of you. Okay, reductive ozonalysis, preparation of ketones through the reductive ozonalysis. Actually, this reductive ozonalysis is applicable for both aldehyde and ketones, and they are very important process. Okay, so separate practice session is there for the reductive ozonalysis. You can go through that. Okay. Now today, after that, after reductive ozonalysis, very simple concept it is, but questions are made complicated. So whenever ozone is used, it is going to react only at the pi bond. And after that, because of the zinc oblique H2O, and you have to be very careful, if H2O it is there, aldehyde or ketone. Okay, make a note of it. And if sometimes here in place of H2O, they will write H2O2, then it is going to give carboxylic acid. It is going to give what? Carboxylic acid. It's a very small change. People don't observe in the reaction, but it is very, very important. This is not reductive ozonalysis. If it is H2O carboxylic acid, sorry, H2O to carboxylic acid, then H2O aldehyde and ketone. This product I am talking about. Okay. Now let us see the next. By the hydrolysis of alkynes. Okay. So here this should be terminal. If it is terminal, then we will use the Markovnikov rule. Okay. We will use what rule? Markovnikov rule. What is Markovnikov rule? The negative part of the adduct. Negative part of the adduct. Negative part of adduct adds to the carbon. Adds to the carbon. Adds to the carbon containing. Adds to the carbon containing less number of hydrogen. Okay, less number of what? Hydrogen. So that is what called as a, what it is called as? Markovnikov rule. Okay, so here we are indirectly adding the H and OH. We are adding what? H and OH. Okay. Okay, here adduct means in this rule, whatever we say adduct means the substance which is adding. So in this one, negative part is OH minus, positive part is H plus. So the negative part of adduct adds itself to the carbon containing less number. See here, there is no hydrogens. So OH will go this side. Obviously, hydrogen will go this side. What is rule and how you have to apply? Is it understood? Organic is very easy to understand but difficult to apply. Okay. So immediately you should know the mechanism. So then see here, R on this what it is coming? OH. On this carbon OH is coming. Now triple bond will convert into double bond and CH is already there, one more H is added. Okay. Now see, there is a possibility in the reaction mechanism. I think we have studied tautomerism. What reaction mechanism? Tautomerism. In the tautomerism, this hydrogen will come here, this double bond will go here. Okay, so then this will be like this R. Okay, see, this is a single bond and this will become as a double bond and CH3. Okay, if you want I will write it separately. Very important, tautomerism, 1,3 migration of proton. Okay, so again I am writing it here clearly. RCOH. Here it is OH and here it is double bond CH2. Okay, 1,3 migration. This hydrogen will come here and this pi bond will go here. Okay, so then resulted tautomer. What it is called as? Tautomer. C double bond oxygen. Okay, and it will be CH3. So like this, C product is formed. What is formed? Product is formed. I think it is now clear, tautomerism. If you got any doubt, you can ask. So this is about the by the hydrolysis. Okay. Now this is what here said. All alkyne except acetylene. Acetylene there is no problem at all because in acetylene means CH triple bond CH. So there is no chance of the ketone because for ketone at least one alkyl group must be there. If no alkyl group, no ketone. So that is what it is said. No ketone is formed when acetylene, but others are forming the ketone according to Markovnikov's rule. Okay. So this is what this slide. Two process, very important process with mechanism we have studied. Okay, next procedure is by hydroboration. By hydroboration oxidation. In the exam, they will write like this. You should understand HBO. Okay, HBO. People confuse us with HBO. HBO means home box office. There is a channel in English channel, home box office, not that HBO. Here, HBO means hydroboration oxidation of non-terminal. Non-terminal means this is a triple bond, this is also alkyl group, this is also alkyl group. When you oxidize by the hydroboration, so whenever you say HBO, that means these are the two reagents. What is this? Diborane in THF. THF already I have explained, tetrahydrofuran. What is furan? What is tetrahydrofuran? Already we have studied the special compounds of ethers. In the ethers we have studied. Okay, if you don't remember, you can check with the cross check with the notes you have written. If not written, go through that video lecture because THF is a very important compound. Most of the places you will find it. Okay. And after that H2O2. H2O2 is used for oxidation. First step is hydroboration. Second step is oxidation. Okay. So here also there will be OH minus added. Okay. See, this is OH minus, one side hydrogen. Okay. So now there will be tautomerism. This hydrogen will come here. Sorry, double bond will come here. This hydrogen will go here. This will result into the ketone. This is a result of the ketone. Okay. Now this is according to anti-Markovnikov rule. These are very same rules we have studied in the alcohol also. alcohol preparation method we can do by the three methods: acidic hydrolysis, second one is hydroboration oxidation, third one is OMDM, oxymercuration demercuration. So among this, hydroboration is a anti-Markovnikov rule, acidic is a Markovnikov rule. Okay, so the differences we have studied. If not studied, you can go through that previous lecture or from your notes. Okay, then unsymmetrical non-terminal alkyne give mixture of ketones. Suppose here alkyl group is different. If alkyl group is different, okay, so then this can go this side also, this side also. That's why they will give mixture of ketones. They will give what? Mixture of ketones. Okay. Next, alkaline hydrolysis. Alkaline means OH. Okay, of non-terminal geminal dihalide, GEM. There are three types of dihalides. Dihalides are how many types? Three types are there. Okay. First one is weak dihalide. Weak means same carbon. Sorry, vicinal, adjacent. Okay. Geminal means on the same carbon. Isolated, that means other than the second carbon. Okay. Three types of dihalides are there. Haloalkenes. In the haloalkane, this classification is made. So this OH will go here. Okay, and another OH will go here. So on same carbon, two OH group is very unfortunate. Okay, because every person, a single person cannot bear one oxygen, because oxygen is so much electronegative. Nobody want to stay with oxygen. But how this oxygen can, this carbon can stay with two oxygens? That's why immediately what it will make, it will remove water molecule like this. Okay, so this is the mechanism. See here. Okay, now this double bond will shift here. So RC double bond OR. Okay, this is what ketone is formed. Okay, this is our ninth method of preparation. Total 9 methods of preparation of ketone we have studied. Okay, so I think all of you remembered. If not remembered, make a quick revision. Okay, because questions, cumulative question, it is very difficult to solve. Okay, now let's see the combined properties of aldehyde and ketones. Okay, lot of questions are there. Why aldehydes are more reactive than ketone? Board exam 3 marks question, 2 marks question. Okay, and in entrance more than one correct. Okay, so it is applicable for both, but how to present yourself in the board exam? So aldehydes and ketones both possess highly polar. This already we have seen. Carbon is positively charged, oxygen is negative charged. Okay. Now carbonyl group has two active center. Okay. So there are two types of reaction intermediate. One is called as electrophile, sorry, reagents. Another is called as a nucleophile. Another is called as what? Nucleophile. Okay. So in the chemistry, if you understand the name meaning, name itself will tell you lot of things. Electrophile, electron attracting, negative attracting. Okay. Nucleophile, nucleus means positive, phile means attracting, philic means attracting. So nucleophile will go to carbon, electrophile go to oxygen. Electrophile will go to oxygen. That's why it is called as a two active centers. What centers it is? Two active centers, electrophilic center and nucleophilic center. Okay, the positive carbon is readily attacked by nucleophiles. See, I have written or not? This is the nucleophile. Electrophile will attack on the oxygen. Okay, however, during addition reaction, nucleophilic attack produces anion which is more stable than cation. Okay, that means both will attack, but first who will attack? Nucleophile will attack first. Okay, who will attack it? Nucleophilic attack will first, then second electrophile. Nucleophile is very fast. Okay, so that's why nucleophilic addition. Okay, attack nucleophile on electrophile is rate determining step. Thus compounds undergo nucleophilic addition. If the question comes why they undergo nucleophilic addition, is it understood? So from where to where you will write for 2 marks. Okay, however, during the addition, otherwise you can write during addition reaction, nucleophilic attack produces anion which is more stable than cation. Okay, from here to here you will write in for the 2 marks. Okay, rate determining step. Therefore, it undergoes nucleophilic addition reaction. Up to the last you will write from here during. Okay, so is it clear now how to present what words are must? Okay. Okay, next slide, let us see nucleophilic addition mechanism. That is what I told you now. Here, nucleophile means it can have negative charge, it can have lone pair or both. Okay, but at least negative charge must be there or lone pair must be there. Now, when it approaches it, see if it is aldehyde, then it will be hydrogen. If it is ketone, then it will be R dash. So Z dash will attack on the nucleophile will attack where? Just now I told you it will attack on the carbon. So once it attacks on the carbon, this pi bond electron will go here. So this will be negative and Z is attached here. Then electrophile is what? H plus. H plus is what? Electrophile. Okay. Z negative is what? Nucleophile. So electrophile, because of this positive charge, it will go and attach here itself. Okay. So this is the mechanism of nucleophilic addition. In the nucleophilic addition, first nucleophile itself will add, then proton will be added. Okay. That is why the solvent or acid. Who will give the proton? Either it can be given by the solvent or it can be given by the acid. I think it is clear to all of you now. Okay. Now let's see the next slide. Okay, next slide, chemical properties. Okay, a poor nucleophile requires an acid catalyst. Okay, suppose this nucleophile is unable to break this bond, then what we require? Acid catalyst to make the nucleophile reaction occur at a reasonable rate. Actually, breaking that bond is very difficult process. Sometimes it requires some speed. That speed is provided by acid. So in that, acid protonates carbonyl oxygen. In that condition, suppose nucleophile is poor. Okay, so this is actually reversible sign. So this H plus will go on the oxygen, then our nucleophile will attack here and then the further reaction will proceed. Okay, so this will be possible only when nucleophile is very poor. Okay, it is very scared about it. It says no, I don't want to go. Then what we have to say? We will send a good acid. You go and start the reaction, then we will send the nucleophile. Okay. Okay, next one. If the attacking atom of the nucleophile, suppose nucleophile can be OH minus, nucleophile can be NH2 minus, okay, it can be anything, have a non-bonding electron. Don't worry about the non-bonding electron, it is lone pair only. Non-bonding electron means lone pair. Why I am giving you this tough word? Because in the examination, if they use, you should know what is that meaning. Non-bonding electron means lone pair. Okay. Then it will form the addition product. Then water will be eliminated from the addition. See here, this is a lone pair. Okay. So this is called as a non-bonding electron. Finally, what we are getting? Water will be eliminated. Okay. This is called as nucleophilic addition followed by elimination. Okay. Up to here it is addition. Up to here it is what? Addition. Okay. Then water is removed, therefore it is elimination. Okay. So there are two reactions takes place, but for this what must be there? Non-bonding electron. Non-bonding electron means lone pair of electrons. Okay. Okay, this is about the mechanism part. Understood? Lone pair, if it is there, what we have to do? Okay. In the previous slide, we have seen What is the previous slide? When it is poor nucleophile, acid catalyst must be used. When it is strong nucleophile, this is the mechanism. Strong nucleophile, this mechanism. Weak nucleophile, this mechanism. And nucleophile containing lone pair, this mechanism. Okay. Now let's see the next one. So relative reactivity of carbonyl. After the question is, what was the question? Why carbonyl group undergoes nucleophilic reaction only? That is the answer. Already I have given you 2 marks question. It can be 3 marks question depending on the format. Okay. So, but another type of question will be there, which is more reactive and why? Okay. Aldehyde is more reactive or ketone is more reactive. If you say answer, then they will ask why. Okay. So aldehydes are generally more reactive. Answer is aldehydes are more reactive than ketone. Why? Because steric and electronic repulsion. Steric and electronic repulsion. Okay. So steric and electronic repulsion means it is not some big thing. See here in alkyl group, in ketone what happens? There will be 2 bulky groups. Okay. And when the nucleophile want to come with electron, they will what they will do? They will repel them. Okay. And nucleophile is unable to go because of the repulsion. That is what called as a electronic reason and steric repulsion. Okay. So, but in case of the aldehyde, what happens? One side hydrogen, another side it will be bulky group also, no problem. So nucleophile can comfortably come and react with this carbon. Is this understood? So this is the first 2 marks question. How you will write? uh, Aldehydes are more reactive towards nucleophilic addition than the ketone because ketones have steric and electronic repulsions, because of which reaction rate is reduced. Okay. And another reason, this is one reason. First reason is bulky groups offer steric hindrance. Other than that, so many reasons are there. Okay, but for the board purpose, this is okay, depending on the marks. Okay. Second is less I effect decreases positive charge on the carbon. Actually, nucleophile is coming to this carbon because of its positive charge, but they are already giving electrons, so positive charge will be less. Okay. Then third, minus I effect increases the positive charge on carbonyl, hence increases the reactivity. Suppose in the ketone also minus I group is there, that time it will improve that examples we will do it. Don't worry, for the competition point of view also. Okay. So we are simultaneously preparing for board exams and competitions. A small little effort can save both. Okay. So fourth one is plus R effect of benzene ring. Carbonyl group is less electrophilic and hence aromatic aldehydes are less reactive than the corresponding aliphatic aldehyde. Okay. These are the 4 points you have to write. Understood? If you want full score and full marks. Now let's see the example sum. Okay. Otherwise we will do it afterwards. Okay. We will do it. Example number 1. Okay. Order of reactivity of the carbonyl compound. See here, less steric hindrance. What you have to see? You have to see the steric hindrance. Okay. The smallest atom, less is the steric hindrance. See here, this is also hydrogen, this is also hydrogen. So highly reactive. Here how many methyl group? One methyl group. And here it is one ethyl group. But this is C. This side also ethyl group, this side also ethyl group. So nucleophile is not comfortable to come to this your place. Is that understood? Now in the next example, see here, this is our target carbon. Okay. Nucleophile wanted to come to this side. See here, it is methyl group is there, here methyl group is there, here ethyl group is there. So more bulky groups, then more difficulty to come over there. Therefore, less will be the reactivity. Is it clear to all of you? Is it understood? Any doubt? I think no doubt. Okay. Second example, chloral is more reactive than aldehyde. Why? because chlorine will be there. In the chlorine, minus I effect. Minus I effect will increases the rate of reaction. Okay. Now see here. Here it is aldehyde. Okay. And here this is the target carbon. But problem is that methyl group is there. Here it is a target carbon. This side also benzene ring is there. This side also benzene ring. So nucleophile don't want to come and disturb this because it is repelled by this both benzene rings. Is it understood? Then fourth one is reactivity of this one. See, minus I effect and minus R effect. Okay. And plus R effect. Okay. Plus R effect. So plus R will decrease the rate of reaction. Minus I will increase the rate of reaction. Okay. So because of this, see, positive charge lone pair is not there. So highest reactivity. NO2 second highest reactivity. No group first. Then plus I group is there. Therefore, it will be less. Okay. So like this question will come in the entrance exam. And board exam, how you have to attempt, already I told you. Benzaldehyde less than propanol because aromatic benzene ring is there. Butanone, propanone, propanol, ethanol. Okay. These are the some previous exam based orders. I think all of you noted this. If not noted, after that you can note down. Okay. Now let's see the next one. Properties of aldehyde. Now we have seen the general properties. Reactions we are going to study now. Okay. So first one is sodium bisulfide. Very, very important. It is used for the test. They will not ask direct test. Okay. They will ask where it is used. Understood? Conversions we will do. Already we have done in the ethers. Okay. How to solve the ether conversions easily. With tricks we have studied. If not studied, if you could not attend, go through that video lecture. Okay. Now properties of aldehyde, addition of the sodium bisulfide. First of all, what is sodium bisulfide? Sodium means Na, bi means H, sulfite means SO3. Is it understood? NaHSO3, sodium bisulfite. Okay. So sodium bisulfite, when it is added, it will form a crystal. Okay. Which is a white PPT. What is this? This is a excellently white colored PPT. Precipitate will be there. Okay. So PPT does not mean that PowerPoint presentation. Okay. Here in chemistry, PPT means precipitate. Okay. So it can be converted into original compound by dilute mineral. So if you add some mineral acid, again it will go back to the same compound. Therefore, it is used as a test to find out or purify carbonyl compounds. Okay. Separating also for testing. Okay. From non-carbonyl compound. Suppose here carbonyl compound means aldehyde and ketone. Carbonyl compound. Okay. Carbonyl compound is there and non-carbonyl compound is there. So when you react sodium bisulfite with this, then it will go and react with only carbonyl. And what they will form? White product, white precipitate. So bring that white precipitate outside and add what do you call? Water. Okay. So then by using the dilute mineral acid, you can convert them again. We will get the same compound. So this is used for separation. I think it is now clear to all of you. Okay. Next one is addition of hydrogen cyanide. Okay. So this is used in the conversions. Previous example was used in distinguishing. This is used in the conversions. When you wanted to add one carbon atom. Okay. Suppose chloropropane to chlorobutane, one carbon when you wanted to increase, then this method is very, very important. Okay. So during conversions, I will tell you the tricks when you will use HC and when other methods. Okay. That is called as ascent series. So one fine day I will take complete conversions questions. Okay. So that you will get in board exam, at least two questions will be there in one part. Okay. So HCN, here HCN will be Cn minus, hydrogen will be plus. Okay, Cn will be minus, hydrogen will be plus. Okay, here Cn minus, nucleophile, nucleus will be attracted by the Cn. So Cn is nucleophile and H plus is electrophile. Is it understood? So Cn will attack on the, here this is CHO. So CHO can be written like this. Okay, instead of this, you can write it like this. So Cn will be attached here, hydrogen will be attached here. Okay, so CH3OH Cn, and this hydrogen is as it is there. Now this is a new functional group. This functional group is called as a cyanohydrine. What it is called as? Cyanohydrine, and it is a reversible reaction. What it is? Reversible reaction and forms racemic mixture. Racemic mixture, how many of you know what is racemic mixture? This we have studied in haloalkanes. Okay, so racemic mixture is mixture of equimolar mixture of the dextro and levo, okay, optically active isomers. Understood? Then the reaction occurs very slowly. So catalyzed by the base, okay, because see OH minus, okay, OH minus is required so that Cn minus can be produced easily. HCN is a weak acid. Okay, therefore Cn minus cannot be produced. Now then Cn minus will be produced if you use the OH minus. Okay, so this is the reason behind why base catalyzed. Okay, why base catalyzed, I think it is clear now. Now let's see the next part. Next part is addition of Grignard reagent. Okay, Grignard reagent general formula you know, I think RMGX. For here example only I have taken methyl group. It can be any alkyl group. Okay, RMGX. What is the nucleophilic part here? RMGX, which is nucleophile, which is electrophile, MGX. Okay, here RMGX, magnesium will be positive and X will be negative. Is that understood? So Mg will be attacking on the oxygen, alkyl group will be attached on the carbon. Okay, so this will be OMGX and alkyl group. So this will go this side, this will be negative, this carbon will be positive. Like here methyl group is there. Okay, so here I am writing it here. CH3C double bond OH. I am writing it clearly now. Listen, check here carefully. It will be used everywhere. CH3MgX. Okay, this will be positive. This will be negative. Okay, so this will go attack here. Methyl group will go attack here. Okay, then it will be CH3C. Oxygen will be with MgX and carbon CH, and already CH3 will be there. Then afterwards what it is written? Hydrolysis. So when you add HOH, then MgOHX will be released. Here it will give you CH3, CHOH and CH3. This is the product. This mechanism will be used everywhere. Grignard reagent is the very utilized reagent. Okay, so have everywhere understood that MgX will be separated as a positive, R will be separated as a negative. Okay, now here which type of alcohol it is, which degree alcohol is formed. So here this is a 2-degree alcohol. How to identify degree of alcohol? I think it is clear now. OH is attached on this carbon and this carbon is further attached to 2 alkyl group. Therefore it is a 2-degree. Okay. So see, formaldehyde will give you 1-degree alcohol, but other aldehyde will give you the 2-degree alcohol. This is what we have studied in alcohol chapter, preparation of alcohol from carbonyl compounds. Okay, so I think it is clear now, all of you. Now let's see the next one. Next one is addition of alcohols. Okay, there are two types of reactions, 1:1 and 1:2. So in 1:1, it is going to give you hemiacetal. Hemi means half. Okay. Same reaction here. H will be plus, O will be minus. So this will, oxygen will be minus, carbon will be plus. So what it will be? Hydrogen will go to oxygen, OR will go to carbon. See, CH3 is as it is. Then OR minus is attached to this carbon. OH, H plus is attached to this oxygen. Okay, this is a hydrogen. Is it understood? Now this is called as a hemiacetal. When it will be formed when the reactants are in 1:1, 1 mole alcohol, 1 mole aldehyde or ketone. Okay. Now let's see the next part. If it is 2 degree, sorry, 1:2. If it is 1:2, what will happen? Okay. See, that time acetal will be formed. See, 2 moles of alcohols are there. What is this? 2 moles of alcohols are used. Okay. Now, both side, earlier this was OH. Now, OH is there. Now, it will be both side OR dash and OR dash because we have taken 2 moles of ROH. This is called as a gem dialkoxy alcohol. Gem means on the same carbon. Vic means adjacent carbon. Okay. So dialkoxy alcohol. This is a stable acetal. Acetal and ketols are hydrolyzed with mineral acid to give corresponding aldehyde and ketone. So it is just like a storage. You will store like this. After that, when you want it back, then we will carry out the hydrolysis. Then we will get back our aldehyde or ketone. Okay. Okay, next one is addition of ammonia. Very important, but few for future reactions. What is importance of this? Here I will underline that important part so that it is urotropin. Okay, urotropin is very important, used in the urinary antiseptic. Okay, so formaldehyde, in this one formaldehyde react with ammonia to form hexamethylene tetramine. What is this? This is called as a urotropin. Name of the urotropin is hexamethylene tetraamine. Okay, so if we react here, here we have reacted acetaldehyde, but if we react formaldehyde, then hexamethylene tetramine will be formed, which is a urotropin. Very simple mechanism. Very simple mechanism. Here NH2 should be written as NH2 and hydrogen. Okay. So hydrogen will go here and NH2 will attach here. Okay. So here see NH2 and OH. But after some time, I don't know what happens. This will be removed as a H2O. Okay. This is removed as H2O, or this hydrogen will be removed as H2O. Then double bond will be there between. Okay. And this functional group name is called imine. What is the functional group name? Imine. Okay. So this OH and this hydrogen. Hydrogen will be removed as a H2O. Then there will be double bond. CH3CH double bond NH. Okay. This is called as imines. Amines means single bond. Imines means double bond. Same way, benzaldehyde, if we react, we will get hydrobenzamide. What benzamide? Hydrobenzamide we will get. Okay. Okay. Next addition of amines. What is the next one? Addition of amines. Okay. Here also same process. There it was amines. Okay. Aldimine. Here it will be ketimine or imines only it will form. C double bond NR. Okay. Same process. There it was NH. Now it will be NR. That, but still it is imines only. But it is called as a substituted imines. That means on the nitrogen, in place of the hydrogen, it will be alkyl group. Okay. Next, addition of hydroxylamine. Hydroxyl means OH. Amines means NH2. Here, what will be the process? same reaction, but only thing hydrogen after this water will be removed. Okay, this is called as a acetaldehyde oximes. All functional group you should note down. Okay, imines means double bond NH is there, imines. If double bond NR is there, substituted imine. Okay, cyanohydrine. Already I told you, cyanohydrine means OH must be there, CN must be there. Then it is called as a cyanohydrine. What it is called as? Cyanohydrine. Okay. Okay. Next, addition of hydrazine. Hydrazine means NH2 single bond NH2. NH2 single bond NH2 is called as a hydrazine. And here H2O will be removed. What will be removed? H2O will be removed. This double bond will be attached here. Okay. This is called as a hydrazone. Hydrazone are very important, especially when naming reaction is there. That naming reaction we will study now. Okay. Okay. Next, addition of phenylhydrazine. Addition of phenylhydrazine. Simple hydrazine means it is NH2 single bond NH2. So phenyl is there. So what we will do? We will erase one hydrogen. Okay. In that hydrogen, what I will write? Phenyl group. Phenyl means benzene. What is the formula of benzene here? Phenyl C6H5. See here. This is benzene. Same product. Okay. H2O will be removed and nitrogen will be attached here. Okay. This is called as a phenylhydrazone. It was hydrazine that will be converted to zone. Zine will be converted to zone. And next one is very important. That's why actually hydrazine is not important. Phenylhydrazine is not important. But to understand what is important, that is we are going to study now. Okay. Let's see that this is what important. DNP test. Okay. 2,4-DNP test. What is 2,4-DNP? Up to here it is called as hydrazine. Now with this it is called as a phenylhydrazine. Now here on the second carbon, fourth carbon, we have nitro group. That's why it is called as a 2,4-DNP. Okay. 2,4-dinitro. D means di, N for nitro, P means phenylhydrazone. Okay. So product will be 2,4-DNP hydrazone. Understood? Reactant is hydrazine. Product is hydrazone. So this is used for the testing aldehyde or ketone is present or not. Okay. In the examination, you will get a questions like this. Compound A gives positive DNP test. Okay. So then what you will understand, Acha, the question is from aldehyde ketone. Now you should shift your focus to aldehyde or ketone. Okay. And if the aldehyde or ketone is there, then it will give either yellow color, orange color or red color solids. Okay. Which is used for identification of carbonyl compound. Suppose you have one compound, you are doubtful that aldehyde or ketone is there or not, then you will send phenylhydrazine to that compound. If it turns yellow color, if it turns orange color, or if it turns red solid, then that is having the carbonyl group, otherwise it is not having the carbonyl group. Is that clear to all of you? I think now it is clear to all of you. Okay, next one is addition of semi-carbazide. Next one is what? Addition of semi-carbazide. Semi-carbazide is very important. Here the question will be there, why this group is involved, why other group is not involved. Okay, the hydrogen of NH2 group is, this hydrogen will be involved in resonance, so does not undergo condensation. See, I will write the structure, detailed structure here. NH2, NH, C double bond O, and NH2. Okay. So this hydrogen only will go and react with the oxygen. There was a question why this hydrogen is not involved. Why? Because see, this is in resonance. This is in resonance, so it is more stable. The substance which is more stable will never be utilized in the reaction. This is unstable, therefore always this hydrogen only you will remove, never touch this hydrogen. Okay, so that is the important question of the semi-carbazide, and product is semi-carbazone. What is the product? Semi-carbazone. Okay, so 2,4-DNP test, semi-carbazide test, both are very, very important. Okay. Now let us see the next one. Addition of X2 and KOH. This is also called as a halo form reaction. Which form reaction? Halo form. Okay. So it is, if it is iodine among the halogen, if it is iodine is there, iodoform. And where it is used to select the presence of this group. Wherever if second carbon is having oxygen, then it is tested by the iodoform. It is tested by iodoform. What it will form? Iodoform it will form. That's why it is called as a iodoform, which is a yellow color. Yellow precipitate it is giving when reacted with I2/KOH also okay, NaOH is also no problem. Okay. So first product will be iodoform and second product will be potassium formate. Okay. And question was about the number of moles of KOH used. So answer should be 4. What should be the answer? 4. Okay. So ethyl alcohol among the 1 degree alcohol containing 2 degree alcohol containing CH3CO group gives yellow colored. Haloform reaction does not affect. Okay. So this is what the importance of iodoform reaction. Okay.